Hello all, in today's video we are going to learn about the fourth lab experiment in the computer networks lab, that is implementing the distance vector routing algorithm. The aim of the program is to implement the distance vector routing algorithm for obtaining the routing tables at each node. If you see, if we have a subnet like this, a small network like this with the nodes, every node will maintain a routing table where the routing table will have entries for all the other nodes in the network, from distance from A to A, distance from A to B, distance from A to C, distance from A to D. It will have the distance between them called as the cost, and what is the next hop information. That information will be given in the distance vector routing table. So our aim is to construct distance vector routing tables for each node in the given subnet. So what all we need to implement this program is, we need to first of all initialize the set of nodes and their distance vectors. There is a video made on distance vector routing algorithm in detail with an example. You can listen to that video to easily understand or easily execute this program. We have to first initialize the nodes and their distance vectors. We will update the distance in the distance vectors using the Bellman-Ford algorithm, which is being explained in that video. We will be doing routing table construction. Every node will update its routing table and construct a table with the new distance and the next hop information. So what are the steps? We need to first have an initialization function where every node will initialize their distance vectors. If there is a direct link between two nodes, the distance of that node will be recorded as the cost. If there is no direct link between the nodes, for example, there is no direct link between B and D, so the distance will be recorded as infinity or -1. You can see here we are doing initialization where we have to draw a matrix here. We have to take an input of the matrix, cost matrix. If it is infinity, then if it is not infinity, next hop information is the next node, or otherwise it is infinity. Then coming on to the distance vector routing algorithm, where I will make use of the Bellman-Ford algorithm to update the distance vectors, where this algorithm will iteratively update the distance vectors. How long we are going to do it? Till we come to convergence, till we come to a common solution. So how do we do that? The Bellman-Ford algorithm says that if there is a path from I to j, either you take the cost from I to j, or you take a cost from I to k and k to j, provided this cost is less than the distance between I to j. See, I am doing the same thing. The distance vector of I to j is compared with the summation of distance vector of I to k and k to j. Okay. Then after that, we'll print the routing tables. Once the initialization is over, updation using Bellman-Ford's algorithm is over, I will print the routing table for every node, where it will show the destination, the next hop information, and the distance or the cost. You can see here, I have written the code here for the given number of nodes. If it is equals to infinity, it will be the cost will be j. Otherwise, I will give the node, I will give the next hop information, and I will give the cost and distance vector. And we'll have a main function where the main function has to initially read the number of nodes, how many nodes are there in the network, and what is the distance between each node, that is given by the cost matrix. So you should take the input of number of nodes and cost matrix from the user, and later in the program you have to initialize the data structure, where you will initialize the adjacency matrix. You will run the distance vector routing algorithm, that is Bellman-Ford algorithm, and then you will print the routing tables. Okay. See here, I am from the main function, I am taking the input as the number of nodes. I am taking the input of the cost matrix. Okay. And I am calling the function for initializing, for performing distance vector routing algorithm and printing the routing table. So this is the same example being taken in the video. So I am taking for my program, I am giving the same input which is there in this one to clarify that we have got the correct output. You can see here. See. So what I have done is, it is asking me the number of nodes. I am taking the same example. Number of nodes I have taken 4. Okay, I have taken 4. Then I give the cost matrix. These are the two inputs we are supposed to give. So I will use the number 999 for infinity. When there is no direct link, it is infinity. I am using the number 9999. So I am taking the cost from A to B is 12. A to A will be anyhow 0. A to C is 9. A to D is 4. So the same network I have taken as example. See the output which I am getting. The output should be what? You are supposed to print the routing table for each node. So node number 0, instead of ABCD, I am telling node number 0, node number 1, node number 2, node number 3. Okay. So for node number 0, if you see the distance vector, okay, what is it? It is 0, 7, 6, 4. I have taken the example problem, screenshots of the example problem which I got here, the final results, and I am comparing with my program output whether it has worked properly or not. You can see the results are same. Okay, then you have to see what is next hop information. Next hop information is the node number we are using. Third is D. So I am using D, D, D. So the next hop information is also being displayed. Then you can see for the routing table for node number 1, what are the distances? 7013. Yes, I got it correct. For the routing table 2, the distance cost is 6102. You can see it is 6102. Let us check the next hop information. D is 3, B is 1, C to C it will be anyhow 0 and D is 3. So this is also correct. Then coming on to the routing table for 3, for the node D for example, that is node number 3. The cost is 4320, which I got in my problem. I calculated, and here also I am getting 4320. That means my program is working correctly. So this is how we are implementing the distance vector routing algorithm, a very, very important concept and a program for the lab experiment also, where we are going to take the input of a small subnet, a small network with number of nodes and their adjacency matrix, and we are going to get the best path with the least cost using the Bellman-Ford's algorithm. So I request all of you all to execute this program and check for the results for different subnets. Thank you.